So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mask code at this side. And today we will be solving yet another problem of POTD. Right? So this problem is given as easy, but I have solved it, and I think that this is not at all easy. It is a medium type problem, right? So if you're not able to solve it, don't feel demoralized. It is a hard problem for me, not a hard, but a medium type, right? You need to be expert with patterns and diagonal printing, right? Okay, so the question is that you haven't given a matrix and you have to print it in diagonal form. The diagonal form is such that you're standing here, right? You see that you cannot go upward any further, so you go horizontal level. You print it. So your current answer is 1. After that 2. Now you go down lower diagonal. So it will be 4. So you print 4. You go here. You see nothing is present here. So you go downwards. You print 7. Okay. Now you go upwards. 7, then 5, then 3. No one present upwards. Go downwards. So it is 6. It is 9. Right? Oh, sorry. Not sorry for my mistake. Yeah. After 6, lower diagonal. So 8. After 8, no element is present. So go horizontally. 9. And you can see all your elements are traversed. Similarly, for a 4 size pattern, it is given that the matrix is square. That is n cross n. Right? N and n are same, not m and n. Right? So you will be here, no upward element, print 1. After that go to 2, lower diagonal 5, no element here, so you will go here. So 2, then 5, then 9, 6, 3, 9, 6, 3. After that no element is present here, so you will go in the direction 4. So 4, then lower diagonal 4, 7, 10, 13. So 4, 7, 10, 13. After that 14, 11, 8. 14, 11, 8. After that lower diagonal or lower element. So 12, 15. 12, 15, and after that 16. So you see that all the elements have been traversed. So this is your traversal, and I don't think that this is an easy traversal. Like, I have solved many questions on traversal, but I find it hard. Like, I have to do some like 30 minutes or so to develop the algorithm. Okay, so I'm not able to think of any brute force approach to solve it. So I will just tell you the algorithm that I used. Right? Okay, so let us write down the matrix. Suppose we write the 3 by 3 matrix. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I will do is I will keep a row pointer as 0 and column pointer as 0, right? The indexes are 0, 1, 2 for columns, 0, 1, 2 for rows, right? Okay. So row equal to 0, column equal to 0, I'm standing here. I will start doing the upward traversal. So I will push that element into the matrix. So this is my 1. I'll go here. I see that the element has surpassed the boundaries. So I see the element has surpassed the boundaries. I will come out of the loop. Okay, I will come out of the loop and I will adjust it such that it returns to this element. It returns to this element, right? Okay, so I have 2 in my hand, and now I will start the lower triangle traversal. So 2 to 4, and then here. So we have pushed 2, 4, right? Now I'm standing here. I'm standing at an index at row equals to column equals to -1 and row equals to 2. Column equals to -1, row equals to 2. Right? I will adjust that. The column becomes in boundary. You can see the row is also in boundary as always, and column is not. So I will adjust it so that it becomes here. Okay. Then after that 7, 5, 3, and then out of bounds. So 7, 5, 3, then out of bounds. I will just adjust it here. Like, no, this time what I will do is, this time is something complicated. So you will see that first of all, I was adjusting only row here or only column here, right? Only row was just being adjusted here, or only column was being adjusted here, right? But in this case, both of them needs to be adjusted. And when I adjust both of them, I come to a node 3, which is already visited. You can see 3 is already visited. So what do I do? When I'm traversing an upper diagonal, right? After traversal, I adjust the values. I adjust row and column, right? I adjust the row and column. Now, if that element has already been traveled or already been visited, right? What do? I just increment my row, because if I'm going upwards, I will have to increment my rows. There are no right elements present because it is an n by n matrix, right? So I will go here, then 6, 8 out of bounds. So 6, 8 out of bounds. Now this element will be turning me back here, right? Because I need to adjust only one column, oh, one row to get it back into the boundaries. Now this element is already travel. If I go to the horizontal level, again this is travel. I will have to traverse one more time. So I will use a loop to get the values inbound. To get the values inbound, right? Okay, so 9 traveled. This is my answer, right? So I don't think that without coding this will be easier to explain, so I will code and explain you one by one. So let me draw the matrix again for your reference, because we will coming again and again, right? So our matrix is 1 2 3 4 5 6 7 8 9, correct? Right. So let us just now let's start coding, and we will understand the remaining things while coding, right? We will understand the depth of it, right? So first of all, to store the answer, I will make a vector int answer, and then I will make int row equals to 0, call equals to 0. These are my 2 pointers, and the size of matrix will be stored in a variable known as n, mat dot size. Now I will traverse the loop until my ans of size is actually less than n star n. Why? Because I know that the traversal will be done, like at the end of it, my answer will contain all the elements, and that is the elements are n into n, right? So I will use that as a factor. Now I will be going upward diagonally, okay, till my first row or my last column is reached. Right? What does that mean? So if I'm traversing upwards, you can see if I'm traversing from 7 5 3, what is happening? I'm decrementing my row number, that is my row pointer, and I'm incrementing my column pointer because I'm going right, right? And this will have this will be continued up till I encounter either the first column first, no, either the last column first, that is the rightmost column, or the first row, that is the uppermost row. So what I will be doing is I will be first checking that if my row I will have to row while my row is greater than equals to 0, that is first row, and my column is less than n, that is last column. Now instead, in the loop, instead of going directly inserting the element, I will just check first that if the element is in the bounds, right? This is just a precaution to prevent the segmentation fault. So if my row is greater than equals to 0 and my call is greater than equals to 0 and my row is less than n and my call is less than n, this skill of writing this row and call, and you learned it from graphs, right? So you can also learn it from graphs if you are following my playback series, placement series, right? And I hope you are watching it. I will be uploading the content very shortly again, right? I was unwell for the last 2 to 3 days, so I was not able to make more videos on placement lectures also. Now, as I said, I will be using mat of 1e9 to mark it unpresent. That I have I have traversed over the element. Now I don't want it again. So what I will do is I will mark it as 1e9. Why did I choose 1e9? Because it's mentioned that the elements can be of 100 to minus 100 range, and this will be helping me after a while when I have to traverse the row below, or I have to traverse the row horizontally, right? Okay, now after this what I will do is row minus minus to go to the next pointer, right? Call plus plus, that is upwards and rightwards. Okay, now if I will check now if my size of ans is equals to n star n. This is just to prevent segmentation fault. When I added this statement, the segmentation fault was not happening, otherwise it was happening. So I really don't know why, because I tried to check it also, but nothing was happening. Okay, so if ans dot size is equals to n star n, break. Now otherwise row equals to max of row comma 0, call equals to min of call comma n minus 1. Now let's see why does this happen. So if suppose I'm traversing, let's see here, I'm traversing this. Suppose I'm here, right? I am here. I go here, I go here, I go here, right? Now, what is my column row number for this? It is -1. What is my column number for this? Suppose this is n minus 1th row. So this will be nth row, right? So I will have to convert it back. So what I will be doing is I will be converting row to uh, I will be converting row to 0 and my column to n minus 1. So I'm actually minimizing my row and minimizing my column and maximizing my row number, right? So I have written that step only. That is row equals to max of row comma 0, col equals to min of col comma n minus 1. Now, in the upward diagonal case, you can see 7, 5, 3. If I'm coming here, I will have to traverse back to 3 and then I will have to go to 3 to 6. So I'm traversing downwards. So in the upward scenario, I will be always going downwards. So while mat of row call equals to 189, that is it is already been visited. What do? You do row plus plus, right? You do row plus plus. Okay. After that, a scenario for the lower diagonal, going diagonally up downwards, right? Downwards. This will be at almost similar, right? So I will just copying it down, just a few changes of minus minus and plus plus. So it will be call greater than equals to 0 and row less than n, right? Okay, the condition will be same for this condition will be same, and I'm now incrementing row and decrementing column. You can see when I'm going diagonally downwards, I'm incrementing my row, that is I'm going downwards, so I'm incrementing my row number, and I'm going leftwards, so that is my column is getting reduced, right? Again, if answer size is as n star n, break it, right? Now, as we discussed, for the row upwards, row equals to max of row comma 0, this time row will go here, something here, right? And row will have to be minimized because row is already upward is maximum weight. It is n and it can be maximum permitted n minus 1. Similarly, column, if I'm going here beyond 7, then column has to be minimized. So row will be getting minimized with n minus 1. If you're not understanding this concept, please rewind back a few seconds and watch it again. You will get it in 2 to 3 times if you're not getting it in single time. Okay, this is not that hard to digest. Okay, after that, as we did this value for row plus plus, we will be doing it for column plus plus, because if we are going downwards and I visit 7 again, I will have to traverse 8, right? So I will be doing column plus plus. If I'm going 6, then 8, then here, then I will see that I'm coming to 7, 6, 8 here, this value. I will be going back to 7, and when I will going back to 7, I will see that 7 is visited. So go to 8. 8 is also visited. So go to 9. 9 is not visited. So start traversal from 9, right? And after that, your answer is completed. Read on answer. Let's see if it works fine. Hope it will work fine. No error will be given. Oh, okay, running fine. So let's try to submit it. In the meantime, please subscribe to my channel because if you are new here, and like the video. Okay, so thank you for watching my video and hope you liked it. And I'll see you tomorrow with a new question and new energy. Thank you. Have a nice day. Keep coding till then. Okay.